Good morning, learners. My name is Mr. Pochilola once again. Welcome to this platform, the YouTube channel, which is run by Black Slides Online Secondary School. This is a platform where you learn the sciences. If you are preparing for the 2026 Msce examinations, or if you are in Form 3 yet to take your exams in 2027, this is your home. This is where you have to visit regularly to learn the sciences. It is on this platform where we groom students. We prepare students fully to face the Msce examinations in the sciences, in biology, physics, chemistry, and mathematics. Welcome once again. If you are visiting this channel for the first time, consider subscribing to the channel so that you don't miss any of our pre-recorded videos. Alright, and also remember to hit the notification bell so that every time we upload a new video lesson, you become the first to be notified, and that's our wish. Our wish is that you should not miss on any of our lessons on this platform. Once again, my name is Mr. Pochilola, your teacher. All right. As long as you are learning on this YouTube channel, lessons are entirely for free. It is my wish that as many of you as possible pass your Msce exams in the sciences. That's our wish. That's our motivation. Our motivation is that you must pass and pass very well. As a matter of fact, get distinctions in all the sciences and pursue your dream degree in the sciences. But if you need a one-on-one tuition, don't hesitate to contact me on the numbers that have been shared here. I'll be pleased to come back to you to arrange tuition, private tuition, at very, very low fees. But remember that as long as you're learning on this channel, lessons are entirely for free. All you have to do is visit the channel to check for newly uploaded videos. Once again, my name is Mr. Pochilola. Wishing you a wonderful learning experience on this channel. So welcome to the topic Msce Physics. This is Msce Physics. We are meeting for a topic called electromagnetic waves. This topic is offered in Form 4. If you are doing a Msce syllabus, you meet this topic in Form 4 Physics. But if you are doing a Cambridge syllabus, you meet this same topic again in Form 5. So, whether you're an Msce candidate or IGCSE candidate doing the Cambridge curriculum, you are both welcome to the channel, and in particular to this topic, which is called the electromagnetic waves. In some context, this is called the electromagnetic spectrum, the electromagnetic spectrum. We shall see what this is. All right. So once again, welcome. Don't hesitate to leave a comment in case you have something to say, whether about your learning experience or the topic, or in particular this lesson. Don't hesitate to leave a comment in the comment section. It is going to be pleasant for me to come back to you to address any issue which you might need to have addressed. So once again, welcome. Invite as many of your friends as possible to join the channel, to subscribe to the channel, so that they too can learn. Once again, my name is Mr. Paul Chilola. I wish you all the best as you learn from me, as we make as many distinctions in the sciences as possible. Once again, you are most welcome. So, like I mentioned earlier on, we are meeting for a topic called the electromagnetic spectrum. The electromagnetic spectrum. I like to say all the time that in order to unlock the understanding of any topic, it is important to define the topic. In order to unlock the understanding of any topic, it is important to define the topic. So, what is the electromagnetic spectrum? Define the electromagnetic spectrum. Okay, we shall define the electromagnetic spectrum in the following manner. The electromagnetic spectrum is defined as a continuous spectrum of waves, which includes the visible spectrum. The definition of the electromagnetic spectrum is simply a continuous spectrum of waves, which includes the visible spectrum, also known as the visible light. All right, so in your 1-mark question, define the term electromagnetic spectrum. It's simply a continuous spectrum of waves, which includes the visible light. Right, so we are defining the electromagnetic spectrum like that. Okay, so such a spectrum, notice that it is a continuous, meaning that there are no gaps between the waves. There are no gaps. That's why we are referring to it as a continuous spectrum. Another word for spectrum is band. So in other words, it is a band of waves. Another word is band. All right. So we can therefore paraphrase or rephrase the definition of the electromagnetic spectrum as the continuous band, which means that it's a group of waves which includes visible light. An example of visible light is light from the sun. Natural light is called visible light. All right, I'm sure you can recall the colors of a rainbow, such as red, orange, yellow, green, blue, blue, indigo, and violet. Together, this forms what is called visible spectrum. It is also called the colors of a rainbow. All right, so that's the definition of the electromagnetic spectrum. It is simply a continuous spectrum of waves. Spectrum is a band or group of waves. You'd also learn that the electromagnetic waves are basically transverse waves. They are transverse in nature. Shall explain what that means shortly. All right, so there are 7 in number. Namely, we have what is called gamma rays, gamma radiation, if you like, whichever is easier for you to say. Gamma rays, gamma radiation. You have heard about X-rays. You have heard about UV radiation, in full ultraviolet radiation, visible light. This is light, natural light from the sun or from other sources of light. It's the one that constitutes the colors of the rainbow. It's called visible light. And then we have infrared, which is also called heat energy or thermal energy. Is also a form or is part of the electromagnetic spectrum. And then we have microwaves, which are used in microwave ovens, which are also used in communication, telecommunication. And then we have radio waves. So take note, how many do we have? We have 7 of these. And these are put together to form a band, which is called spectrum. So such a band is known as the electromagnetic spectrum. So this thing here, which we have here in form of waves, is the electromagnetic spectrum. It is a continuous spectrum of waves. Which waves? Gamma rays, X-rays, UV radiation, visible light, infrared, which is also heat, microwaves, and radio. So there are 7 of them. So if you watch TV at home, or you listen to radios such as Times Radio or Zodiac Radio, or whatever radio station you are listening to, then just know that you are using radio waves, which are part of the electromagnetic spectrum. I hope so far so good on the definition of the electromagnetic spectrum. What is the electromagnetic spectrum? It is the continuous spectrum. Another word for spectrum is band. I mentioned that earlier on. Just a group of waves, which includes the visible spectrum. By visible spectrum, we are referring to the group of the 7 colors of the rainbow, which are red, orange, yellow, green, indigo, and blue, indigo, and violet. In short, Roy Gibbs. All right. So that's what we have. Okay, so we can proceed having defined the electromagnetic spectrum, which I thought could be necessary to define. All right, we can proceed. So, the electromagnetic spectrum is divided into 7 bands. I mentioned earlier on that the electromagnetic spectrum is divided up into 7 bands, which is in order of decreasing wavelength. We have radio waves. Okay, so the electromagnetic spectrum is divided into 7 bands, which in order of decreasing wavelength are the radio waves, microwaves, infrared, visible light, UV radiation, X-rays, and gamma rays. Welcome, learners. This is your home. This is where you prepare your future in the sciences. All right, you are in trusted hands, in safe hands. Don't leave this place. This is where you belong. We want you to do your best to pass your Msce in the sciences. Or if you are doing a different curriculum, such as the Cambridge curriculum, you are welcome also. This is your home. All right, so once again, the electromagnetic spectrum, which we defined earlier on, is divided into bands, which are in order of decreasing wavelengths. We have radio waves, microwaves, infrared, visible light, UV radiation, X-rays, and gamma rays. All right, so as you move from radio waves descending down, wavelength decreases. So wavelengths. Remember wavelengths? In Form 3 you learned about wavelengths. I'm sure this is not new. So let's say you're moving from radio, progressing all through to gamma rays. The distance between identical parts of the wave is called wavelength. Right, so in this case, we are referring to this distance. So this distance keeps decreasing. It becomes smaller and smaller and smaller. That's what we are talking about. So this distance decreases. So radio waves have the largest wavelength, followed by microwaves, followed by infrared, visible light, UV radiation, X-rays, and then we have gamma. Gamma has the least wavelength. This distance for gamma is very, very small. That's what we are saying here. So as you move from radio waves to gamma rays, what happens to wavelength? Wavelength is just the distance between two adjacent crests, or between two adjacent troughs, or simply the distance between any two identical points, or between any 2 points which are in phase. You can define wavelength in many ways. That's covered in Form 3, so we don't have to worry about that here. Welcome once again. My name is Mr. Pochilola. Please, if you have not subscribed to the channel, consider subscribing to the channel. And also remember to hit the notification bell so that you don't miss on any videos that I upload in future. Great. This is your home. All right, so learners, it is important to note that we have 7 of these in the spectrum, namely radio waves, microwaves, infrared, visible light, UV radiation, X-rays, and gamma rays. All right, so if you suppose you are given these in any order, and you're asked to order them, to rearrange them in order of decreasing wavelengths. So don't forget the order. Okay, so moving from radio waves to gamma rays, wavelength decreases. That means the opposite is the case. Moving from gamma up to radio waves, there's an increase in wavelength. So an exam question could be, arrange the following electromagnetic waves in order of decreasing wavelength or increasing wavelength. So you should know this order very well. It will be disappointing to miss a question that simply requires you to order, to arrange them. Welcome, learners, to the platform. Apart from listing the electromagnetic waves in order of decreasing wavelengths, another criteria for arranging or listing electromagnetic waves is in order of decreasing frequency. Remember, frequency is the number of oscillations, complete oscillations made per second. Frequency. All right, so let's say we are looking at a wave function consisting of electromagnetic waves from radio to gamma. All right, so frequency is simply the number of oscillations, complete oscillations made per unit time. As you move from radio to gamma, the number of oscillations made per unit time increases. Okay, so when listing these electromagnetic waves in order of increasing frequency, you start from radio waves, because the radio waves have the lowest frequency, while gamma rays have the highest frequency. So the order will change. And also, this order will apply to increasing energy. The higher the frequency a wave has, the greater the energy it transmits. All right, that's very important. Energy of a wave is related to its frequency by this equation. don't mind it, where F is frequency, so that's frequency, and the H is a constant, which is called Planck's constant. Don't worry about this now. They'll come out clear as you pursue physics further than this, further than MSc level. But suffice to say that as you move from radio, okay, so let's say we are looking at these, all of them together. So we have radio waves, microwaves, infrared, visible light, UV radiation, X-rays, then gamma. So this listing is in order of increasing frequency. So the opposite would be the case. Moving from gamma back to radio, it means now the order is decreasing frequency as well as decreasing energy. Okay, so from radio to gamma, frequency increases, but from gamma back to radio, frequency decreases. So you may be asked again in an exam to arrange the electromagnetic waves whether in order of decreasing wavelength, which we looked at already, or increasing wavelength. You should know which one is to start with. If you are looking at the order in terms of decreasing wavelength, it means you start from radio waves to gamma, because gamma, honestly speaking, has the least wavelength. All right, but in order of decreasing frequency, it means you have to start from gamma to radio waves. Remember that you would recall from 3 physics the equation known as the wave equation, which is given by speed of a wave is equal to frequency of the wave multiplied by its wavelength. Okay, so if you make frequency this subject, then it means you shall have speed divided by wavelength, for which speed is constant. It means frequency depends on the wavelength of the wave. In this case, it means we shall have a relationship. Frequency is inversely proportional to wavelength. Okay, so the higher the wavelength of a wave, electromagnetic wave, right, the lower will be the frequency. And the opposite is true. Electromagnetic waves that have high frequency, it means they have low wavelength. For example, gamma. Gamma has the least wavelength, therefore it has the highest frequency. All right. Once again, my name is Mr. Pochilola, your teacher on this platform. It is my pleasure to be with you on this platform. Please don't go away. Watch the lesson up to the end. Wishing you a wonderful learning experience on this platform. So in order of decreasing frequency, it means the first one shall be gamma rays, followed by X-rays, then ultraviolet radiation, visible light, infrared, and the microwaves, and then lastly radio waves. So know this order very well. It also follows that if we are to arrange these in order of increasing frequency, it means we shall start from the bottom going up. So in order of increasing frequency, we shall start from radio waves to gamma rays. This is increasing frequency. But also remember, in terms of wavelength, it means this is decreasing wavelength. As wavelength decreases, frequency increases. All right, so we are saying frequency is inversely proportional to wavelength. The higher wavelength is, the lower the frequency. That's why frequency decreases as we go down, because radio waves have very high wavelengths and the very low frequency. And the opposite is the case. The lower the wavelength, the higher will be the frequency. As you're going up from radio waves to gamma, wavelength decreases, therefore frequency increases. Very important. If this is your first time to visit this channel, don't hesitate to subscribe to the channel so that you don't miss on any of our videos. So waves with the lowest frequency have the least energy. A wave that has very high frequency generates or transmits very high amount of energy. So this diagram here shows you the order in order of decreasing frequency and also in order of decreasing amount of energy the wave generates. Remember that waves transfer energy, okay, without transferring matter. Okay, so gamma rays therefore have the highest frequency and so the highest amount of energy. Let's close today's lesson by looking at the common properties that are common to all electromagnetic waves. By saying all electromagnetic waves, we mean all the 7 electromagnetic waves that form the electromagnetic spectrum. So whether you are looking at the radio waves, microwaves, infrared, visible light, UV radiation, X-rays, or gamma rays, all of them have common properties. So we are saying all electromagnetic waves, including light, have the following common properties. All of them transfer energy. The energy is given by the equation E. I think I mentioned this, that energy of a wave is given as E equal to a certain constant H, which is called Planck's constant. Don't mind it for now. Multiplied by its frequency, F. So all electromagnetic waves transfer energy. All right? They transfer energy. All of them transfer energy. All electromagnetic waves are transverse waves. By transverse, recall, a transverse wave is represented by a simple diagram like this one. they are all characterized by this waveform, whereby the vibration, the oscillation, the direction of the oscillation is at 90 degrees to the direction of the propagation of the energy. Such a wave is called transverse. Recall the definition of a transverse wave. It is one in which the oscillation, the vibration of the particles, the direction of the vibration of the particles is perpendicular to the direction of the propagation of the wave, as opposed to longitudinal waves in which the vibration of the particles is parallel to the direction of the propagation of the wave. Alright, so suffice to say that they are all transverse in nature, meaning the direction of the vibrations is perpendicular to the direction of travel of the wave. Alright, so they all carry energy, and they are all transverse waves. Take note. All electromagnetic waves travel at the same speed through a vacuum. This is what you call the speed of light. The speed of light is 300 million meters per second. Okay, so all electromagnetic waves travel at 3 times 10 to the power 8 meters per second. So take note. This is one of the constants, the values that you must commit to memory. The speed of light is 3 times 10 to the power 8 meters per second. So don't forget that. Or if you forget to present it as the power of 8, as the power of 10, simply write 300 million meters per second. So all of them have the same speed. That's why you are told that the speed of light, which is visible light, is 10 to the power 8 meters per second. It's the same as 300 million meters per second. All right. Properties of electromagnetic waves. They can all be reflected. All right. They can be refracted. They can also be diffracted. By this we mean that when such waves hit an obstacle, they can be sent back. Let's say we have the waves traveling like that in this direction. This can be sent back. That's a process called refraction. A reflection. So they can be reflected. Remember, reflection is the sending back of a wave when it hits an obstacle or surface. So the waves can be sent back, or they can be refracted, meaning they can be bent when they pass through different media. Let's say initially traveling through air and then through a different material, like that. That's called refraction, where we have a normal line here, and also not forgetting we have a normal here. All right. They can also be diffracted, meaning that they can pass through a gap. All right, let's suppose we have two obstacles that are separated by some gap. So a wave oncoming, approaching the gap, is going to diffract. To diffract means bending around corners, like that. So this is a tendency of the waves called diffraction. So we are saying they can all be reflected, they can be bounced back, they can be refracted, that it means they can be bent or they can pass behind obstacles. They can pass behind obstacles. My name once again is Mr. Pochilola, your teacher on this platform. Once again, if you have not subscribed to the channel, consider doing so that you don't miss on anything. All right, so just an additional note that 300 million meters, which is the speed of all electromagnetic waves. Remember, these are supposed to be 8 zeros, so there's another 0 there, which is 3 times 10 to the power 8 meters per second, is the same as 186,000 miles per second. Of course, in your exams, you'll not be required to present your answer in terms of miles, because miles is no longer an SI unit. All right, so once again, welcome. Consider inviting your friends, wherever they are, to join us so that they also learn and benefit from the channel. So another important note is that, all right, so through air, light and other waves travel at about the speed of which we have talked about. But through denser substances, for example, glass, the speed drops force. All right, so this value which we have mentioned, the speed of these electromagnetic waves can apply whether in air or in a vacuum. Remember, vacuum is an empty space. So this speed in air as well as in a vacuum is taken to be the same. It's taken to be the same. So through air, light and other waves travel at about the same speed as 300 million meters per second. So if anyone asks you what is the speed of light or in the air, just quote this one. What is the speed of light in a vacuum? Just quote the same. So these are the properties that are common. But remember that despite having these common properties, the electromagnetic waves are different from one another. One, how they have different wavelengths. Two, they have different frequencies. And thirdly, they transmit different amounts of energy, as we saw. So once again, my name is Mr. Pochilola, wishing you a wonderful time. Meet you again in our second lesson on the same topic called electromagnetic waves. Bye-bye for now. Wishing you all the best in your studies.